Have I given my light switch speed?
Yeah.
I don't
You
know.
don't understand why the light switches work, but they work.
I don't understand anything.
Wait, which half? Because if it's the first half, that's worse than the second half.
No, the second
This
half.
first half, second half, I usually don't say anything about. All right, under exponents, ladies and gentlemen. Put a ginormous little word here that says negative. And as a little subtopic to the subtopic there, please understand this. The only time negative exponents are your friends is with scientific notation. The only time you really are allowed to keep negative exponents in math is when we talk scientific notation. Every other time they're really not very useful, helpful, and they're almost sometimes evil and diabolical, if you will. Now let's think about this for a minute. I'm not sure what the best way to go about this is. Maybe this. Okay, let's say I have 10 to the 5th power over 10 to the 3rd power. What does that mean except this? That means I have 5 tens times themselves, right? Just nod your head if that even makes any sense to you. So you have 10 times 10 times 10 times 10 times 10. And then on the bottom I have, somebody chime in here, 3 tens times themselves, right? And we know that if you have the same factor on top as on the bottom of a fraction, Caleb Fisher, what can you do? Yeah, cancel them out, right? This 10 will cross off with that 10, this 10 will cross off with that 10, this 10 will cross off. The 3 on the bottom cross off with 3 of the 5 on top, leaving you with, look at Zach, even Zach came up with this. 10 to the 2nd power. So what you say? Well, what you say is this, okay? The way I get, without having to do all this, the way, there's what's called the exponent rule, maybe we've done this before, in that if you have the same bases on top, and they have exponents, you can, rather than doing all this, you can just subtract these two. 5 tens on the top minus the 3 tens on the bottom give you the 2 tens that you ended up with. Not earth-shattering? Latent? Not earth-shattering at all? Alright, here it is. This is where the dramatic drum roll may come in. Drum roll, you have to stop when I give you the stop. It doesn't sound good on the camera. What if my problem had these flipped over and the 5 was on the bottom? 10 to the 3rd over 10 to the 5th. Well, using the same philosophy we just did, you know, I would, if I wrote all these out, I have 3 tens on top. I'll just do it again to not to prolong or beat the proverbial dead horse. These 3 tens would cross off with these 3 tens on the bottom. Okay, but remember, when you cross off stuff, you can't. When you cross off stuff on the bottom, you're still left with the 1, but whatever over 1 is still whatever. But on this, if everything on top crosses off, you have to leave that 1 there. And then what am I left with on the bottom? 10 times 10, which is 10 squared, right? 10 squared. Okay. Which is what? 10 squared is, I end up with 1 over 100 here, right?
Yeah.
And again, you say, so what?
So what?
All right, here it is. This is the culminating moment where Clausen will go, Yeah, that makes a lot of sense. Ready? Not till I'm done. What did we do here? We took 5 minus 3 and got 2. Same rule applies for this, except it is 3 minus 5. And when you take 3 and subtract 5 from it, you get negative 2. 1 over 100 is the same thing as 10 to the negative 2 power for this very reason. Which Chase says, what? What in the world? All right. What negative exponents tell you is that you have a fraction, and whatever that exponent is, that's what the positive exponent is, the thing on the bottom. Let me give you the deductive leap on that again. Here it is. Okay. If I have 2 to the negative 6th power, that was as if I had a whole bunch more 2's on the bottom than I had on top. For example, if I have 2 2's on top, which is 2 to the 2nd power, right? Over 8 2's on the bottom. How many got? 2, 4, 6, 7, 8. If I use that little thing here where I subtract 8 from 2, what do I get? I get the negative 6 thing I do. If I cross all these off, these 2 cross off with those 2, I still have a 1 on top. And what do I have on bottom? 1, 2, 3, 4, 5, 6. 2 to the 6th power on the bottom. Now, for those of you that are off in la-la land and this makes no sense to you, you don't have to understand why. For the same reason why the light switch thing is on and off, you don't understand why it works. This is the reason why, but here is the fix. Here is the fix. And this should be what you write in big letters here. If I have 2 to the negative 3 power, okay, here is your fix. You don't have to understand why this is, what it is, or where it is. You just have to understand what to do to the process. Like that. Just like planting a seed. Who's the farmers in here? All right. Can you explain to me why when I put a seed in the ground it grows? The process of it. Can you explain? Yeah, I know that you put water on it, it grows, but why does it grow? What's inside that seed that makes it grow? How does it pop out of that little hard shell? Huh? How does it work? What's inside that little thing of corn that makes it grow? Huh?
Corn or soybeans.
Well, let's go corn.
Okay.
When I put the seed in the ground, what's inside the seed that makes it grow?
Roots.
There's roots inside the seeds?
No. Anyway.
What I'm pointing at is here.
No. There's a seed inside
Nobody, I mean, you can't really explain it. Maybe, I don't know.
It grows out of the seed.
Well, I know, but what makes it grow? What can you say? Why when I put this piece of paper in the ground, doesn't it grow into more paper? What's different about a seed than this piece of paper?
Because it's not living.
A seed, actually, I believe it's dead until you put water on it, doesn't it? I don't know. Anyway, what I'm getting here, Emily, is you don't have to be able to explain to me why this works. You just need to know that it works and you do it. I know that if I put a seed in the ground and it gets water and it gets sun, it's going to grow. I don't have to understand why it grows. I just know. Anyway, here's the deal. You can change any exponent from negative to positive by moving it from the top of a fraction to the bottom. And then in parentheses, or vice versa. And you may not understand that yet, but you will in just a second. Right, Grace? You're with me, aren't you? That's, I haven't explained. You'll get there, Zach. And before I proceed, please make a little eye contact with me right here, because I need to tell you this. This will be where you'll make a mistake. Some of you have a hard time with this.
Everybody's staring.
Joseph, Vivians, look at me. Andrew, there you go. Eyes, mind, and ears. Look. Got it, got it, got it, got it, got it. A negative exponent has nothing to do with whether your answer is negative or positive. Just because there's a negative exponent, don't tell me my answer is negative, because you don't know that, nor does that tell you that. Got that? Negative exponents have nothing to do with whether the answer is negative or positive. Now, going back to this little thing here. What this means is this. I don't like negative exponents. I can change negative exponents to positive by, if I were writing this out in fraction form, it would look like this. If I want to change my exponent to its opposite sign, I just put it, if it's on top of a fraction, I put it on the bottom of the fraction, which means the 2 and the 3 go on the bottom, but the exponent becomes positive, and I always have to have something on top of a fraction, so I put a 1 up there. 2 to the negative 3rd power is the same thing as 1 over 2 to the positive 3 power, which 2 to the positive 3 power is 2 times 2 times 2 times 2. 2 times 2 times 2 is 8. 2 to the negative 3rd power is the same thing as 1/8. I can't change it, that's just what it is. Notice it's not negative 1/8. Just because that's a negative exponent does not make that negative. So you don't have to understand why that works. I explained why it works. If you got it, good. If you don't, then whatever. Let me give you another one. So what is 5 to the negative 2 power the same as? It's the same as, notice it's a fraction like this. I flip-flop the things, 1 over 5 squared, which is 1 over 25. 1 over 25. Emma, what was your question?
Do you mean, like, every time we try and make the fractions positive by doing that?
You will, generally speaking, you always want your exponents to be positive. Conversely, if you saw this, you know, if my fraction was 1 over 3 to the negative 2 power, I would make this exponent positive by putting it on top. So it would become 3 to the positive 2 power over 1, which is simply 9, because 3 times 3 is 9. Again, note, negative exponent did not make this answer negative. You're just moving stuff around. Now, unless you thought that was even part of the tip of the iceberg that we have to talk about, why are we talking negative exponents, Connor? What's your question?
So like what is like 1 over 5 to 7 power? Are you
Wait.
You have to like completely go to the 1 over 8? Like that first question they asked us? Like yeah, do you have to do the same? Like
Do you have to make it this?
yeah.
Yeah, I would, if you're simplifying it. Now, if it's something grandiose, I don't know, if it was 8 to the 15th power, I'm not sure so I'd spend any time on that. I know you wouldn't. You need to go find yourself a ruler. Okay, now, the reason that we do this, children, is because, let me see if there's something else we have. Oh, no. Wait, we did law of exponents, didn't we? We did, good. Good, then I don't need to worry about that. The reason we do this is because of scientific notation. Bum, bum, bum. I don't think, have we done small numbers? We haven't done small numbers. All right, so take out your notes under scientific notation. I told you the only acceptable place where we keep things as negative exponents is the scientific notation. And I suppose it would be good for us to do this. Think about this. 10 to the negative 1st power 10 to the negative 2 power, 10 to the negative 3 power, 10 to the negative 4 power. What do those things mean? What is 10 to the negative power in the real world? If I gave you 10 to the negative 1 power dollars, how much money have I given you? How quickly you forget? How do we change 10 to the negative 1 power? How do we change that? How do we change that into a positive exponent? Anybody? I can do that. Come on. It is dime. Why? Because I make this exponent positive by putting it under 1. 10 to the negative 1 power is the same as 1/10. Because 10 to the first power is 10. Guess what 10 to the negative 2 power is? It's going to be hard. 10 times 10 is... Guess what 10 to the negative 3 power is? Guess what 10 to the negative 4 power is? 1 over 10,000. Now, the reason... Wait, did I do that? No, that's right. So, here's the deal. If you come up with... Remember scientific notation? Let's go big number first. 6, 7, 3, 0, 0, 0, 0, 0, 0... Wait, sorry. 0. How did I change that into scientific notation?
6 times.
Really? I quit if you can't tell me how to do scientific notation.
6 times.
Somebody, please, somebody out there. Lauren!
You have to put a decimal and then the numbers less than 10.
Make the number so that it's between 1 and 10. So you start with the decimal and you move it all the way over here till you get it to the number so that it makes it between 1 and 10. So I get 6.73. Then what? Times 10, right? And then what's my exponent? Chase?
9.
How many places did I move it? 3, 6, 9. Got that? Let's review. Today what we're doing is what happens when we have small decimal numbers like this. How do I make, what is that? Tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. 52 10 millions. How do I write that in scientific notation? Follow the same rules, make it between 1 and 10. So where's the decimal going to go to make it between 1 and 10? Madison Sittler, I think you can handle this one. Where will I put the decimal so my number now becomes between 1 and 10?
Oh, between the 5 and 10.
Between the 5 and the 2. I'm going 1, 2, 3, 4, 5, 6. So I get 5.2. Stop me there if that don't make no sense. Step number 2, you write down times 10 just like we did up there. But the difference is now, see with this one here, 10 to the 9th power is 100 million. So I multiplied 6.73 times 100 million and got this. Here, I'm not multiplying, but I actually technically have to divide this by something to get back to this. And that's why it ends up being a negative exponent, because if I multiply one of these things times this, it's like taking 5.2 divided by 1,000. But the rule is just, you just count decimal places again. 1, 2, 3, 4, 5, 6. But you put a negative up there. It's 10 to the negative 6th power. Because you are taking 5.2 times 1 over 1 with 6 zeros after it. You don't have to do this, but that's just what you're doing. And if you did that, you would just move the decimal back to there. So this is scientific notation for smaller numbers. Yay?
Yay.
How about this? 0.000000000000412. In scientific notation, that would be... Somebody give me an answer for that. answers we have? Joseph, we have not heard from you today. What do you got?
4.12 times 10 to the negative 12 power.
You sure it's negative 12? I don't know, I haven't counted. I'm just asking Joseph. I'm not saying you're wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Joseph, you are a gentleman and a scholar. Have we multiplied scientific notation times scientific notation?
Yes.
We have or haven't? So maybe you can understand the importance of this, Brian Dietrich. Okay? Because if I gave you this problem, do I have some room up here? If I gave you this problem, 0.00045678910412 and told you to multiply that by 3 let's just stop there. And I said multiply those together. And I said multiply those together. How many of you would look forward to doing that problem? Not many of you. But if we changed it to scientific notation and did the problem, which would be this, 4.12 times 10 to the negative 12, and I multiply that by 3 times 10 to the what power is that? 9th power. Look how easy the problem is. 3 times 4.12 is what? 12.36. Just take my word for it. What do we do when we multiply? What do we do with exponents? And what do you get if you add a negative 12 and a 9? Oh boy. You have 12 negatives, 9 pluses. What do you end up with? You have 12 negatives, negative, 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 and you have 9 pluses. They cross off, a plus crosses off with a negative. What are you left with?
Negative 3.
Negative 3. And there would kind of be my answer, except I can't leave it as this. We did this, didn't we? Move the decimal there. 1.236. What do I do with this then? We know. Make this smaller. Make that bigger. There's the answer to your problem. Much simpler, much quicker, and much easier than if you tried to multiply that out. Most of you, I'm guessing, would have got that wrong. You don't have to do that, so don't ask me a question about that. You won't be doing that today. Now, what I do need you to do, though, is look in your book on page 350 and 351. Watch this there. Watch. Ready? Touch it. Because there's quite a bit that could be confusing on this section here. Let me stop this. I don't know what to do this time. Let's see if you can answer. We're going to do the practice together. That would be all of us, you and me together, trying to learn a little bit about each other here. 350, ready? So back here again. 3 to the negative 2 power, Lauren, would be what? Simplify. Your page 350, please. Just tell me, what would be 3 to the negative 2 power? Honestly, how long does this take? You can flip more than one page at once. 3 to the negative 2 power, Lauren, is... Did we miss the whole thing? This is not that hard. Who thinks they know what 3 to the negative 2 power is? Change the negative exponent to positive by moving the number underneath the 1. 3 squared is... So the answer is no. 3 to the negative 2 power is 1 over 3 squared, which is 1/9. Right? How about letter B? Letter B. What is 2 to the negative third power? Layton? 1/8. Letter C. 5 to the 0 power. That's not a new one, by the way. Anything to the 0 power, ladies and gentlemen, clausing is? Anything to the 0 power is 1. Letter D. Now, before you get all bent out of shape here, 2 to the negative third power times 2 to the third power. You don't have to say this is 1/8 and that is 8 and multiply them together because these are like bases. If like bases are this, what do you do with the exponents? What do you do with exponents? When we had 10 to the 5th and we multiplied it by 10 to the 6th, you got 10 to the 11th. What is negative 3 plus 3? Anything to the 0 power is? The answer to this is 1. If you did it out, it would be 1/8 times 8 over 1. And that would end up with 8/8. But you shouldn't have to do that because you can add exponents. As long as the bases are the same. I can't do that with this. You can't have 2 to the negative 3 and multiply it by 3 to the negative 2 power. They're not like bases. You couldn't add those together to get your answer. You'd have to actually do that out. Sometimes I feel like just letter F. 10 to the negative 3 times 10 to the negative 4 would equal 10 to what power? Cassandra Malis. Letter F. 10 to the negative third times 10 to the negative fourth. We're just looking for what exponent would go next to 10. You don't have to figure out what number, what fraction it is. What's your best guess, Cassie? With negative what? We're adding. Not multiplying. Negative 7. You see why that is? Because you're adding negative 4 with negative 3. You add these together. You don't multiply them. Ooh, so far so good. Oh boy. Letter G. I think something's wrong. There has to be, because you know what I have for an answer that cannot be true? You know what they have? Anybody take a guess what I have for an answer? I have negative 3 for the answer for G, but that is not possible. It can't be negative 3, because 10 to the negative 3 as a fraction is what? 1 over anybody. 1 over what? 1 over 1,000, because it's 1 over 1 with 3 zeros. Does yours have it, Joseph?
Mine doesn't even have an exponent. No, it's not in the book, but I have it in my notes.
Oh, we have it. Oh no.
Uh-oh.
Can I have a collective groan from you? Look at letter. I only say that because look at letter H. Look at it again and groan. And groan deeply. I want the biggest groan you could possibly do. I apologize for this, but we have to talk about this. Look at letter H. It has x to the negative 3, y to the what? Y to xy negative 1. I will entertain any thoughts on this problem.
Okay, so I don't.
Come on, I need some clausing. I can tell you're thinking deeply about this. How can I simplify or fix this? There are 2 different ways you could think about this. Anybody? Oh boy. Well, I'll take a random guess here. Is that great?
So you combine the y with the y to the negative 1 power, then you get y, and then you take the x and combine it with nothing, because there's no other x with the
Yes, there is.
power.
Oh, here, let me fix it for you. It doesn't have a power, it's a 1. Zachary said this, and listen, because he had some great words of wisdom. This is all multiplication. So he said, you take the y squared and you put it with the y to the negative 1. What do you do when you multiply like bases that have exponents? You add the exponents together. What do I get if I add 2 and negative 1? 1. So these both just cross off and give you a y to the 1 power, or y. Same thing with the x's. X to the negative 3 and x to the first gives you x to the negative 2. Now, the only thing I can tell you is that's an unacceptable answer. Somebody say why?
Why?
The teacher help me.
Teacher, help me.
The teacher's always right.
The teacher is always right.
I told you this. The only time negative exponents are acceptable to use in math is with scientific notation, and this is not scientific notation. So I got to figure out somehow to get that negative 2 to a positive 2. But I gave you the whole light switch thing. Matter of fact, if you look in your notes under what we just wrote down, I think in big words I wrote to change negative exponents to positive exponents. That's why you're in the So tell me what the solution to that would be. How do I make that x to the negative 2 and x to the positive 2? Joseph, I know you've got this quick before Miss Young gets here because I'm writing and I can't answer. Let me get Joseph to answer this. What do we do to get negative exponents to positive exponents? Somebody, anybody, quick! Oh, I didn't. I'll give him. Did you guys just get in there now?
Can I go get them?
Sure. Not only that, I don't know why you wouldn't be doing this math. All right, kids, open up to your section under exponents. We are going to read this together and in unison. I will pull it up. I want you to read yours, not mine. Ready? And if you can't read it together, we will write it together 127 times. Together, in unison. Ready? You can change any exponent from negative to positive by moving it from the top of a fraction to the bottom of a fraction, or vice versa. Now, I have to put a little addendum in there because this could be confusing. Okay? By moving it, put a little arrow there with its base. Because you can't just move the exponent, you have to move the base that is with it. Somehow, when I woke up this morning, I didn't realize this math was going to be this confusing. Now, hopefully you have an aha moment.
Yes.
Ephraim, did you finish your math and those sentences?
No.
Why would you be in break? Why would you not be working on it now? So let that be your hint. I think you better be working on it, sir. Get after him. All right, back to this here thing here. Do we need to read it again, or can somebody tell me what you think you should do? Please, somebody, don't make me go back to that other slide.
Negative 3 would be negative 2 at the positive x to the positive to the bottom would be 1 on top.
Grace, please help me. Help me, Grace, help me. See, but the deal is the y has a positive exponent, so you don't want to move it because it's already okay. It's only the x to the negative 2 that's bad. How do I make the x to the negative 2 a good x to the negative 2? All right, here we go. One more time.
You
And change any exponent from negative to positive by moving it from the top of the fraction to the bottom, or vice versa. Would it help if I did this? I don't know.
Yes. So 1 to x to the positive 2.
Wait. I have an offering back here, John.
Change it to 1 over x to the.
Well, what about my y? The y stays. John said exactly what it is. I need to make this a positive 2, so I take the exponent and its base. It's on top of the fraction. I move it to the bottom of the fraction, and the exponent becomes positive. That's all you have to do. It's just that easy. The y stays because its exponent is already positive. If I would move it to the bottom, the exponent would become y to the negative 1. So your answer should be y over x squared. That is it. You need positive exponents. If you want a 1 there, that's fine. If not, all right, one more. Now, this collective grunt won't be quite so bad. Sometimes it has to get darker before it gets light. That next problem there, letter I, 6x to the negative 2, y to the third, z to the negative 1, all over 2x, y. Now, let me tell you, you can't have more than one x or y in a term, so somehow you got to get all those x's and y's together, and all the exponents have to be positive. Sitler, you got any ideas for me? We can probably figure out the number. What happens to the number? 6 over 2 is going to have, what's going to happen? And what you're going to get? 3. So let's just start with that. Don't worry about the numbers because 2 goes into 6 3 times. So you end up with a 3 on top. Now what do I deal with the numbers? Or letters? No, letters. Ooh, Madison, yes.
The y cross off because the exponent is
Sure. There's one y on the bottom and how many y's on top? 3. So what's going to happen is this y will cross off with one of those y's and I'm left with what on top? Y squared. Good for you. Way to avoid the negative ones. Emily, you got a suggestion for me now? Now I have these goofy negative exponents to deal with.
Let's just not worry about them.
Go back to the little phrase that we read. How do I change them to positive? It's not a hard process, people. How am I going to make this z a positive exponent? Somebody move it to the bottom. I'm just going to take this whole thing and put it down here. It becomes z to the positive 1 power. Now what am I left with? Because I dealt with this, I dealt with all this. I'm just left with an x to the negative 2 and an x. Ooh, somebody, I see lights. Don't worry, it's not all this hard, just this one. Connor?
You put it to the bottom and it becomes just 1x.
Well, let's put it to the bottom. What does x to the negative 2 become when it becomes on the bottom? X to the second power. It just becomes positive, so that's gone. But now look, I've got an x squared and an x on the bottom. What do I get? X squared and x is? X to the third power. And there you go, ladies and gentlemen. When the proverbial smoke clears, you're left with a 3 and a y squared on top and a zx cubed on the bottom. Notice no negative exponents, everything's positive, and everybody's happy. Wow. Who felt like math today was kind of painful? Leighton, not you? That is interesting to me at times. Very interesting. We have 4 minutes. What I want for you to do, I really don't know what else. There's no way we have time for it.
Just one over here. Somebody have a good proposal.
Well, we have to give you a lot because I took half away from people because they used the ruler, right? I should tell you what, wait, who is my ruler users? Diedrich.
Yes.
I'm going to let you tell me what